Example number 2. Sketch the graph of the following quadratic function, y equals negative 2x squared plus 14x minus 20. Let's graph this thing using the tools that we have already in our tool belt. Our x and y intercepts, our axis of symmetry, and let's find our vertex. First things first, our y-intercept, we substitute x equals 0. So then y is simply negative 20. Okay, so if I were to say that as a coordinate point, that would be 0, negative 20. Now I'm not going to plot that right now because we don't know where the other points are, so we need to choose an appropriate graph or an appropriate scale for our graph, and we'll only do that when we have all the points that we need. Our x-intercept, that means y equals 0. So 0 equals negative 2x squared plus 14x minus 20. I notice that I have a greatest common factor here, and that's negative 2, so I'm going to factor that out. Negative 2, and I have x squared minus 7x plus 10. What I love about that is now my a becomes 1, and it's a simple quadratic. It's simple factoring, not complex factoring. So I'm going to divide both sides by negative 2. 0 divided by negative 2 is 0. Negative 2 times this polynomial divided by negative 2 is simply going to be that polynomial, or that quadratic. X squared minus 7x plus 10. So then we have 0 equals factored form x minus 5, x minus 2, because when you add them together it's negative 7. When you multiply them together it's 10. So my x1 is 5, and my x2 is 2, because all I'm doing is I'm solving using factoring. So if I were to put that in coordinate points, that would be 5, 0, and it would be 2, 0. So I have all of my x and y intercepts. Great! So when we're looking for the equation of the axis of symmetry, I like to give titles to my things because it helps me organize my thoughts. X equals x1 plus x2 divided by 2. X equals 5 plus 2 divided by 2, which x equals 3.5, or 7 over 2, or 3 1/2, however you want to do that. And now I'm going to get a little bit squishy here, but that's okay. I'm just going to section it off. I'm going to say my vertex. I know that my point is at 3.5, but I'm going to substitute my 3.5 in for my x to solve for my y. That's the glorious thing about equations. If you know one coordinate point, you can plug it in and you can get the other coordinate point. So y equals negative 2, and I'm going to go to the original equation, negative 2 and 3.5 squared plus 14 times 3.5, I'm just going to zoom in here, minus 20. Okay. So I'm going to grab my handy dandy calculator. 3.5 squared is 12.25. So 3.5 squared is 12.25 times negative 2. So that's 24.5. Negative 24.5 plus, and we have 14 times 3.5. 49, so that plus 49 minus 20. So we have 24.5 negative plus 49 minus 20. So we have a vertex at, well, the y portion of the vertex is going to be 4.5. All right. So if I were to say my vertex using coordinate points here, I'm going to say the vertex is at 3.5, 4.5. Great. So let's graph this thing. I know that my y-intercept is at -20. Sometimes our y-intercepts are a little bit big. So what I'm going to do for this one is I'm just going to disregard having to create a scale. Because this one right here we have 5 and 2 and we get 3.5 and 4.5. So if I give my scale of 1 in the x, remember to label your axes, and 1 in the y, that is going to give me a sufficient kind of shape. So if I were to plot my x-intercept, I go 1, 2, 3, 4, 5. There's one of my x-intercepts, and 1, 2. And my vertex is at 3.5, so 1, 2, 3.5, and 4.5. 1, 2, 3, 4.5 right here. And I know that this is -1, 2, 3, 4, 5, 6, 7. We know that it will not cross the y-axis because it doesn't cross until 0, -20. So when I draw my parabola, I want to make sure that it doesn't cross. Now you're noticing that this parabola, this is actually a little too pointy. Maybe I could do a better job here. It kind of looks more like that. Yeah. Okay, so that gives us our shape. You're noticing that it's opening down. Now that, just a little bit of a sneak preview here, but that's because our coefficient in front of our x squared term is negative. If it's positive, it will open up.